Your single-person empire is a masterpiece of modern engineering. Your revenue engines are automated, your tax shields are deployed, and your profits flow into tokenized real estate. But if you store your entire business intelligence, your customer databases, proprietary source code, and historical ledger backups, inside a single centralized cloud bucket owned by Amazon, Google, or Apple, your empire rests on a fragile foundation. One automated corporate policy update can wipe out your entire digital presence overnight. The truly independent digital architect does not rent space from big tech monopolies. They build an unassailable data perimeter. By deploying decentralized Web3 storage protocols and encrypted distributed networks, you can shard your corporate data across thousands of global nodes, ensuring your systems remain completely online, uncensorable, and immune to single point of failure outages. In this chapter of our Infrastructure Mastery series, I am going to strip away the illusion of traditional cloud security. I will hand you the exact technical blueprints to construct a self-contained, decentralized data backup system that costs pennies to maintain and cannot be shut down by any corporate entity. Subscribe, secure your local terminals, and let's download the sovereign data grid. Traditional business managers believe that paying for a premium corporate cloud tier makes their data safe. This is a severe operational blind spot. You do not own that server. You are merely renting access under a terms of service contract written by corporate lawyers. If an automated algorithm flags a legitimate file as a false positive, your business execution can stop instantly, and recovering access may take time and additional verification. Our data sovereignty pipeline begins by eliminating raw, readable files from the cloud ecosystem. The moment your business automates a daily ledger report or standardizes a customer metadata file, Node 1 triggers an automated script that breaks the file into dozens of unreadable, encrypted fragments. No single server holds the complete picture. Each one stores only encrypted fragments. We do not upload data to specific physical server farms. We utilize the interplanetary file system and decentralized protocols like Filecoin or Arweave. Your encrypted database shards are distributed globally across independent cryptographic nodes. To retrieve your files, your automated backend queries the network using unique cryptographic hashes, reconstructing your data in milliseconds from different points around the globe. Look at the system layout running on your screen right now. True digital resilience requires a hybrid framework. Your real-time operations run on lightning-fast edge servers, but your critical historical backups are split dynamically. 50% drops into secure decentralized Web3 storage, while the remaining 50% automatically syncs with a physical, encrypted local server terminal running inside your private workspace. When you store corporate intelligence inside a standard cloud provider, you rely heavily on that provider's security and availability. A decentralized data grid adds another layer of resilience through cryptographic validation and distributed storage. Because your encrypted data is spread across many independent nodes, no single server failure can compromise the integrity of your backups. Traditional tech gurus want you to believe that managing your own decentralized data grid requires a multi-million-dollar IT department and complex server maintenance routines. They often recommend expensive software subscriptions as the only option. In reality, many open-source distributed backup solutions can be deployed with relatively simple automation scripts that run quietly in the background. By activating this decentralized storage network, your single-person enterprise gains a highly resilient backup strategy. Your data becomes more portable, your workflows become less dependent on any single provider, and your infrastructure gains greater operational flexibility. But to link this sovereign data grid directly with your automated customer outreach while preserving user privacy, you need a carefully designed communication layer. Censorship does not just start with deleting files. It often begins with analyzing metadata. Centralized cloud providers can process information such as file names, creation dates, and access locations to manage their services. A decentralized architecture can encrypt metadata before transmission, reducing the amount of information exposed during storage and routing. Traditional SaaS models often lock your business into recurring monthly storage fees. If you stop paying, access to your data may eventually be suspended. Some decentralized storage protocols, such as Arweave, are designed around an upfront payment model intended to support long-term data preservation, transforming recurring storage expenses into a one-time infrastructure investment. Look at the technical architecture executing on your screen right now. You do not manually drag and drop files into your decentralized network. A local cron job running on your terminal detects any change in your operational database, compresses the new records into an encrypted container, and pushes the update to the distributed layer every midnight, creating seamless data redundancy without a single mouse click. If your customer interface relies exclusively on traditional domain registrars, your online presence depends on centralized infrastructure. A decentralized architecture can also incorporate blockchain-based naming systems such as ENS or Handshake, providing additional options for accessing internal services through distributed networks. The security of your decentralized infrastructure depends heavily on protecting your access keys. You should never store system passphrases or PGP private keys in plain text or unsecured cloud documents. Instead, dedicated hardware security devices and strong authentication practices significantly reduce the risk of unauthorized access. Many people assume distributed databases are inherently slow. In practice, modern decentralized storage protocols rely on global peer-to-peer networks that retrieve data from multiple geographically distributed nodes, helping optimize download speeds while reducing dependence on any single location. When you build valuable automated workflows on centralized infrastructure, protecting your proprietary business logic becomes increasingly important. Strong encryption, access controls, and zero-knowledge architectures help reduce unnecessary exposure of sensitive operational data to third parties. Your single-person business is no longer dependent on one physical office or one technology provider. Your applications run across cloud infrastructure, your financial systems are diversified, your investments span multiple asset classes, and your critical data is distributed across resilient storage networks. The result is a more flexible and robust operating model. This represents a resilient architecture for a modern single-person enterprise. By reducing dependence on centralized infrastructure, increasing redundancy, and automating critical systems, you create a business designed to remain operational even when individual services experience disruptions. In the final block of this decentralized grid installation, I am going to walk through the core terminal commands, introduce the open-source frameworks behind the system, and show you how all of these components fit together into a practical deployment. To deploy your autonomous backup node, your local terminal executes a sequence of storage commands that connect your encrypted files to decentralized networks. These commands define where encrypted backups are stored and how they can later be retrieved, creating an automated backup pipeline with minimal manual intervention. Now let's look at the long-term resilience of a distributed data network. Traditional cloud deployments may become unavailable if a provider experiences regional outages or account issues. A decentralized architecture distributes encrypted fragments across many independent nodes, allowing data to remain recoverable even if portions of the network become temporarily unavailable. Modern businesses often rely heavily on centralized cloud ecosystems because of their convenience. A decentralized strategy offers an alternative by distributing storage across independent networks, reducing reliance on any single provider while maintaining control over critical business information. Rethink what business intelligence really means. True long-term value isn't just measured by your account balance. It's also measured by how well you protect your proprietary software, customer relationships, and operational knowledge. A resilient data architecture helps preserve those assets over time. While some businesses spend valuable time reacting to cloud outages, account restrictions, or unexpected platform changes, a well-designed distributed backup system continues operating quietly in the background, automatically protecting your most valuable information around the clock. Throughout this series, you've seen the complete blueprint for building a modern solo digital business. From recurring software revenue and efficient financial structures to resilient storage and automated operations. Combined, these systems create a business designed for long-term independence and adaptability. The internet continues to evolve beyond centralized platforms. If you want to follow this journey into decentralized infrastructure and practical automation, subscribe to the channel, enable notifications, and comment grid below. We have assembled a resilient business infrastructure that combines software automation with distributed storage networks to protect your data, streamline your operations, and strengthen your digital foundation for the years ahead. But once your distributed data infrastructure is fully operational, another challenge appears. How can autonomous AI agents manage customer acquisition and business workflows efficiently while maintaining privacy and minimizing dependence on third-party marketing platforms? If you want to build the revenue engine capable of supporting this entire infrastructure, click on the video now appearing on your screen. There, we break down a practical AI-powered development workflow for launching your first digital asset from scratch.